All right, let's think about this second example. F of x equals the square root of x minus 2. Now we just saw that the range is rather hard to compute, so we'll now just think about only the domain. So the question is, what's the domain? All right, can you plug in 1? If you plug in 1, what do you get? Square root of negative. Can you have a negative, square root of a negative? If you do, then you get an imaginary value, and I stated that in pre-calculus, whenever we write functions, we only limit functions that take in real values and gives you back real values. We never deal with complex valued functions. So that's like a tacit agreement when we do pre-calculus, okay? So 1 is illegal because that would make an imaginary output, non-real output. So that's no good. Can you plug in 2? Is square root of 0 allowed?
Yes.
What is square root of 0? 0. So that's fine. Okay. So 2 is okay. Can you plug in 3?
Yes.
Yes. So 2 is okay, 3 is okay, and it looks like everything after 3 is 2 is good, right? Okay. So on the number line, I noticed that a lot of people, when taking the last exam, you guys weren't really using the number line. Just for the sake of partial credit, you should draw the number line, okay? Yeah. So draw the number line, and what are we saying? 2 is good, and everything after 2 is good. Okay. How do you write this as an interval notation? 2, what should I draw here? Yeah?
Bracket.
You need a square bracket, comma,
Infinity.
and then parentheses. Okay. So you have 2 to infinity, that's your f of x. Let me give you a second example. Let's call this example 1. Second example. All right. How about f of x square root of 3 minus 2x? What should our domain be? Okay. Can you plug in 2? 2 times 2 is 4. 3 minus 4 gives you negative. So 2 is no good. Okay. 3 is even worse. 3 times 2 is 6. 3 minus 6 will be negative, right?
It's 1 in any negative number.
Okay, so you can plug in 1. 1 is okay, right? If you plug in 1 times 2, 3 minus 2 is 1, so that's okay. And you can plug in 0, you can plug in any negative number. For example, negative 3, negative times negative is positive, plus 3 will be positive. Almost. But you forgot that there are more numbers than just integers. There's some decimals that you would be neglecting if you just said the domain is 1 and before. You would want to say that's the solution, but that's not really true. You can go a little further to the right. Can you think of any number?
1.5.
1.5, right. How did you get that number? You just guessed? Okay, well,
no,
I mean,
because it'd be 2.5. So you would 3 minus 2.5 would be a half.
okay, all right. So the way you figure that out is to think about when this produces 0. So look, 3 minus 2x equal to 0. That gives you 3 equals to 2x. And that gives you x equals to 3 over 2, which is 1.5, right? So in other words, if you plug in 1.5, this entire thing becomes 0, and that's the highest x could be. If x becomes slightly bigger than 1.5, then suddenly this becomes negative and it's no good. Does it make sense? Yes.
So basically, that inside the square root, we don't want it to be 0 or negative. We want it to be positive.
you want it to be 0 or positive, but not negative.
But not negative.
Yeah, so you want to make sure that this is non-negative.
So we can plug any number we want, but we just can't make it go negative.
Yeah, so finding the domain is basically what number can you plug in? You're trying to answer that question, right? And we're arriving at the following answer. The answer that we just figured out is that you have 1.5 here, right? And this seems to be the maximum value of x you can plug in. Anything after, so this is okay until here. Anything after is illegal. It will make the inside negative, and it's no good, okay? Everything before would be great. 1.5 itself is great. So what's the domain?
1.5 to negative.
Oh, you should always write down the
Negative.
smaller number first, okay? So if you say 1.5 to negative infinity, that's a no-no, okay? You don't, that's wrong, okay? You should always write negative infinity up till 1.5. Even if I wrote down this arrow this way, and you're tempted to write 1.5 first, you never do that, okay? So that's the domain. Now, we just figured this answer out by trial and error, right? So it's probably better if we can come up with a more systematic solution, right? So let me give you a systematic solution. So here's what we should do. Solution of this thing, okay? We need that 3 minus 2x is greater or equal to 0 because it's inside the square root. Okay? Anything inside the square root cannot be negative. It could be 0 or greater. Okay? Now I can add 2x both sides, and I get 3 greater or equal to 2x. Now I can divide both sides by 2, and I get 3 over 2 greater or equal to x. So that's the condition. Okay. Now in the set theoretical notation, you can write your domain in the following way. Domain equals to all x such that x is less or equals to 3 over 2. That'll be one way to write down the domain. Okay. So this is a descriptive set notation. Okay, so domain is all x such that x is less or equal to 3 over 2. That's 1.5. The same thing as here. Okay? So it's the same answer. Or you can draw the number line and write down this domain. Like that too. Okay? If you took the time to draw the number line and you wrote down the interval notation, you can write the interval notation this way. Okay? So my point is, when you see a square root, just write down the radicand should be greater or equal to 0, solve the inequality, and that's the domain.